Okay, so this assignment this week is all about interfaces. So what is an interface and how do I use it? So a couple of quotes from the Oracle's website. Oracle is the company that maintains the Java, the standard Java implementation. So first is kind of their non-technical explanation of what is an interface or how is it used. There are a number of situations in software engineering when it is important for different, separate groups of programmers to agree to a contract that spells out how their software interacts. So you got two different groups, and they are both writing software. The software's got to interact, and they've got to agree upon how those separate pieces of software are going to talk to each other. Each group should be able to write their code without any knowledge of how the other group's code is written. Generally speaking, interfaces are such contracts. So that seems like it makes some sense, right? Here's the technical definition. In the Java programming language, an interface is a reference type, similar to a class, that can contain only constants, method signatures, default methods, static methods, and nested types. Okay, so some of that makes some sense, sort of in a vague way, right? So it's similar to a class, but it can't contain all the things that a class can contain. It can have constants. It can have method signatures. That's to say that you can declare methods, but you cannot give the method a body, nothing inside the squiggly brackets. Default methods, we won't worry about that. Default methods are outside the scope of this class. Static methods, you should know what those are. We have implemented static methods. We've talked to great detail about static, so I won't go into that right now. And nested types. Nested types are like default methods in a, well, in that we won't talk about it in this course. It's beyond the scope. So we don't need nested types or default methods to do interesting things. So we've seen interfaces before. So early on, last semester, excuse me, in the game of NIM, we implemented the action listener interface. And that allowed us to listen to button presses. In the maze generator, we also implemented the action listener interface to allow us to listen to button presses. And we implemented the adjustment listener interface to allow us to listen to the scroll bar event. So when they adjusted the scroll bar, we could get information out of that because we implemented adjustment listener. In the fireworks application, we did things very different. We implemented mouse listener and mouse motion listener because when we would click and drag and release, we would launch out fireworks, and we wanted to listen to mouse events. And we also implemented the runnable interface because it was an animation, and animations need something that's constantly updating, independent of everything else that's going on. And to have something that's constantly running, independent of everything else, we need to implement the runnable interface. The audio application implemented Action Listener, also for buttons, and the runnable interface, because we wanted the thing reading from the microphone and writing to the speakers to be going on independent of other things. And so we needed something that was runnable. For the digital images application, we implemented Action Listener to listen to buttons again, and Mouse Motion Listener to listen to the mouse movement events. You say, well, I don't remember the mouse motion listener. What did we do with the mouse and the digital images? That was all about just clicking buttons, right? Well, not exactly. The digital images application would listen to your mouse when your mouse rolled over the image, and it would grab pixels from the image and display their RGB values up near the top. You may have missed that little piece, but it was there. The Yahtzee project, which you completed very recently, had an action listener to listen to buttons and an item listener to listen to checkboxes. And you might say, well, the game of NIM had checkboxes. Why didn't it need an item listener? Well, the difference in the game of NIM, we weren't listening to events on the checkboxes. We were using them to just store information, and when they clicked the button, the action listener was then able to go back into the checkboxes and figure out which ones were checked. In the Yahtzee project, we had an event or something that happened the very moment they checked the box, and so that's why we needed the item listener to listen to the checkboxes. So let's group our interfaces into some categories. Okay, so we've used listeners to capture mouse events. We can also use listeners to capture key events directly. Okay, that just means we directly capture directly from the mouse or directly from the keyboard information about what's going on with the mouse and keyboard. We also have listeners or interfaces designed to be used in conjunction with pre-built components that can be added to a JFrame. Those are your listeners, your listener interfaces that will capture events related to buttons and slide bars and checkboxes and things of that nature. And then we have some interfaces that are used for other things. And our runnable interface is one that's used for other things. Another one that I would like to talk about, hopefully this week, is the comparable interface. And so let's get into a little bit more detail about each of those three categories. So listeners used to capture mouse and key events directly. Mouse listener allows the programmer to write methods that get called whenever the mouse buttons are pressed. Mouse motion listener allows the programmer to write methods that get called whenever the mouse is moved or dragged. The key listener allows the programmer to write methods that get called whenever a key on the keyboard is pressed. So the mouse listener is just, pressing the buttons and releasing the buttons. The mouse motion listener is when you're moving the mouse or moving the mouse with the button down. And the key listener is for pressing and releasing on buttons. Listeners used in conjunction with pre-built components that can be added to a JFrame. So action listener allowed us, the programmer, to write methods that get called when the user clicks on a button or a menu item. The item listener allows the programmer to write methods that get called when the user clicks on a checkbox or types into a text field. And we have not really used text fields, but if we know item listener, all we'd have to do is look up text field and it should be fairly easy to figure that out. Adjustment listener allows the programmer to write methods that get called when the user adjusts a scroll bar. Alright, so interfaces that are used for other things. This is the last category. Runnable allows the programmer to write a method that can run at the same time as the main thread. Okay, so that you can have a method that runs independent, continuously, and independent of everything else that's going on in the program. And then the comparable interface we'll talk about allows the programmer to use some pre-built fast sorting and searching methods of the collections class. So there's a class called collections, which allows us to do some things on anything that is a collection. We've used array lists before, and array lists are collections. If we create our own class, and then we create an array list for that class, and then stick a bunch of instances in it, we can quickly sort them using the collections class. It's got a sort method. But in order for that sort method to work, our class has to implement the comparable interface. Not only can it sort them, but once they're sorted, it can quickly, very, very quickly search for a particular item in the list. And so that's incredibly useful, being able to sort and search items in a program. So in the next video, I will begin going through these interfaces and looking at code and showing you how to use each one of them. Happy watching.